Overloading of trucks causes a lot of problems like destruction of road and highway, killing people, road blockages, etc. Overloading reduces the control of steering and braking, causing accidents. In addition, frequent overloading reduces the productive life of the truck as well as the productive life of the road. So keeping this issue in mind, we the team ATECS are here with an easy and durable solution to cope up with this problem and reduce overloading. This is an example of ICR Pro 1110. This truck has a maximum payload capacity of 9,000 kilograms, and a gross vehicle weight of 11,990 kilograms. The maximum speed is 87 km/h. At first, the truck has 3 infrared sensors fixed in the carriage. It is protected with a metal casing. In the metal case, is a waterproof cabin for the infrared sensor. A passive infrared sensor is an electronic sensor that measures infrared light radiating from objects in its field of view. It is an electronic instrument used to sense some aspect of the surrounding by emitting or detecting infrared radiations. It has a measuring range of 10 to 80 centimeters and covers an angle of 20 to 60 degrees. These infrared sensors sends a digital signal to the microcontroller if any obstacle is detected, before the process of calibration. The carriage sits on a mild steel sheet with thickness of 8 millimeters. The properties of this sheet are that it has high tensile strength, high impact strength, high shear strength, etc. There are a total of 4 load cells used to get accurate readings. These are low-profile load cells commonly known as pancake load cells. They are efficient, reliable, and highly accurate, having a maximum capacity of 10,000 kilograms. Signals from each cell is sent to the junction box. The junction box averages the signals and sends a single signal to the black box. The black box consists of 3 major circuits, that is the GSM module, to send message to the regional transport office if overloaded. A load cell amplifier consisting of 24-bit ADC, to send the accurate measurement to the microcontroller. A microcontroller circuit, to analyze all the inputs received by the sensors and output message on the screen. The black box gets stable input, through the voltage regulator from the battery. An external battery also can be added if required. The black box sends an output to the monitor in the driver's cabin. The monitor is an OLED display ensuring low consumption. The home page will have some buttons like an emergency stop, which can be enabled whenever anything goes wrong, a warning signal which lets you know if the sensor needs calibration, etc. The help option includes guide, contact details, updates and software information. When the start button is pressed, a calibration process begins. It checks for infrared sensor's response. If the infrared sensor sends a high signal to the microcontroller, it indicates that the carriage is full and hence can't proceed. If the infrared sensor sends a low signal to the microcontroller, it indicates carriage empty, and a green signal turns on letting you add in the carriage. Once the calibration process is complete, it will tell you to click on Done. When you click on Done, it will tell you can't add more weight, but if your weight is less than the rated weight, you will be allowed to add. If the vehicle is in motion, it will lock the load sensor, but if the vehicle is stopped, it will show unlock, making the load cell active to weigh. If the weight exceeds, it will give you a time of 5 minutes to unload it, till the max capacity is not obtained. It would send the message to the regional transport office if it exceeds the time limit.